Ladies and gentlemen, welcome to the European Robotics Forum 2017 in Edinburgh. We are happy to be here, and we will now have the opening ceremony where Bernd Liepert, the president of EU Robotics and also the Chief Innovation Officer of KUKA, will give the opening speech. But before that, we have a teaser presentation, so to say, about how science can be turned into a deliverable system. And this talk is made by Tim Endert, the Chief Commercial Officer at Tharsis, one of our members. Tharsis is a designer and manufacturer of autonomous systems robots, and Tim has been actively involved in the development of major robotic systems for a UK logistics company and is now entering the service. And everyone knows here that we are turning more into service robotics, and this is exactly one of the reasons also to have him here. He has played several technical roles, including Cambridge consultants and a number of commercial and technical roles, and has a background in electronics and communications from the University of Bath and an MBA from the University of Cambridge. And I would like to welcome Tim Endert to give us his presentation. Please.
Thank you very much, Reinhard. Fantastic. Well, good morning, everybody. I have to say it's a great privilege to me to be able to be up first at ERF 2017. On reflecting in preparation for the event, I couldn't help feeling like it is a great time to be involved in robotics at the moment, and a great crowd who are gathered here today. I wanted to spend a little bit of time, though, talking to you first about a topic which is quite dear to my heart, and I find it very easy to confess to not being the most intelligent person in the room, but I hope that's not why. And that is the idea of how do we make things simple. But first of all, I thought I'd start by just telling you about an interaction that I witnessed just a few weeks ago with a piece of technology which just made me start thinking about this. So this is kind of a domestic scene. So this is a couple of weeks ago. I have to say I was a very lucky man. One Sunday morning, my wife was cooking pancakes for breakfast. As you probably imagine, many of you have done this before, you have to get the pan quite hot. As you're starting to cook, it starts to smoke a little. And I guess I, like many of us in the room, are a little bit of an early adopter of technology. So I have some lovely Nest smoke alarms in my house. And as you probably experience if you have one, when the smoke goes off, you get a wonderful, calm but alerting voice from the Google Nest lady saying, alert, alert, there is smoke in the kitchen. The alarm may sound, it may be loud. And what happened immediately after that is my young son jumped up from the kitchen, ran up and said, Daddy, what's happening? What's wrong with the smoke? Why is there smoke in the kitchen? I said, it's okay. Your mum's just cooking pancakes. It made a bit of smoke. It's fine. And kind of pacified, he's like, okay, fine. So, and he wandered back to the kitchen table, and just as he walked under the smoke alarm, he said, it's okay, it's just the pancakes, and went to sit down again. And I guess this kind of made me think two things about the technology which we'd got in our house and we were living with. So firstly, what an amazingly complex amount of technology which Nest had squeezed into a very tiny box. It sensed the smoke, it was able to speak in an intelligible way. Not only that, but the one which is in the upstairs of my house was giving the same warning. Huge amount of technology squeezed into a small box running off a small number of batteries. But then secondly, it didn't do everything my son wanted it to do. It would have been really great, actually, if you could just say, don't worry, it's just the pancakes. So it was a great product, but the guys at Nest had to make a decision that we're going to stop developing now, and we're going to get the product into the market so that it can benefit people, so that we can learn about how people really interact with it and what else they need. And I guess that made me reflect that actually all of us who are scientists, engineers, technologists, through the ages, our role has really been about making things which, on first hand, may appear magic, into something which is simple and everybody can use. So, the well-cited example of the smartphone, it is completely magic that I have a slab in my pocket which allows me to communicate with anyone in the world instantaneously and find pretty much any piece of information I would like. And I guess I had a sense that where we are today in the robotics sector is very much on that journey. So we are today on the cusp, I would say, of being able to see finally the mass deployment, mass adoption of robotics in many different applications, many different sectors. But today, the general public, I guess, broadly view robotics as complex. They see it as the stuff of car factories, of university research, of which many people here will represent, and of some really exciting startup companies. And I guess the challenge for all of us as a community over the coming years then is, how do we take that amazing technology and convert that into something which is simple and everyday use and is understandable by the general public? Now, Tharsis's role, as Reinhard kindly said, is as a designer and manufacturer of custom robotics and complex electromechanics, and getting those into market on behalf of our customers, who tend to be large service businesses. So we are very close to, and kind of it's dear to our heart, the idea of actually getting stuff deployed and getting it into the market. And so a continuous focus on what does this machine really need to do in the first iteration, and then a long list of potential wants and things you'd like to be able to do may come later. So an example of where we've been working recently, and we can talk to you more about this downstairs, I'm really pleased to be able to tell you this week, is we have been working over the last several years with our friends at Ocado to design and develop and now manufacture the robots which are in their new warehouse in the south of the UK. If you haven't seen the system, it is, I would say it's a pretty revolutionary approach to goods handling and logistics, particularly for groceries. So there is a densely packed stack of crates, all stacked on top of each other, which go to a depth of several meters, with no aisles, no rows. And on the top surface, there is a chessboard-like grid with a swarm, a fleet of robots, which move up and down in X and Y, collecting the groceries, taking them to the edge of the grid, where a picker, which is human or robotic, can take the tomatoes or the cucumbers or whatever, put them in your shopping basket, take the crate away, and then another robot brings the next item on your shopping list. So this kind of approach has allowed Ocado to move from it taking several hours to pick one customer's order to a matter of minutes. So it's a really exciting system, and we've been really pleased to be part of the project. It is deployed today in their Andover site in the south of the UK. This is some images which Ocado have only just been starting to release, so it's really well timed that we can talk to you about it this week. One of the really exciting things about it, of course, is that this is now starting to deploy these robots at scale. So in Andover, by the time it's fully operational, there will be a fleet of 1,000 machines picking groceries and delivering them to people in the south of the UK. There is the next facility which they are in the process of building, which is in East London, which will have 3 times that number. And so this has been a great case study, if you like, in actually getting machines into market and deploying them at scale. So, but talking about simplicity, what can we learn from that? Clearly, this system is complex, has many, many pieces, and I've no doubt that many of the pieces of technology that people in the room are working on are similarly complex. For the piece that we've been working on, which is the machine itself, the robot platform, just a few examples or a few thoughts of how we have taken this philosophy of making complex things simple with the aim of being able to get machines into use so that we can start providing some value, and of course so that we learn, because when you actually deploy them, you learn a ton. So these machines have to accelerate and decelerate pretty fast, and they have to stop with positional accuracy to a millimeter or so, because each of these machines are running very close past each other, and they have to stop to be able to do a turn in 90 degrees. So clearly these machines need some level of traction control. Now when we first started doing the development, we didn't really know what the parameters of that were going to be. We didn't know how complex it was going to be. So the approach we took, therefore, was to, rather than doing a detailed kind of mass and dynamics and kinetics model of the whole system, we just ensured that there were more sensors and feedback points than we were going to need on the machine, which allowed us to deploy it into the field and learn by doing so. Another example, I guess, would be that, common with many of these kind of mobile platforms, the economics of deploying them relies quite heavily on how long it takes to charge the battery versus what the runtime is. Again, we didn't take the approach of saying, well, let's model it out, because at that time we didn't quite know what the chemistry was going to be. We didn't know exactly the dynamics of the operation of the site. So in terms of looking at a really simple example like the charge connector, we simply just borrowed a technology from a neighboring AGV application. We had to repackage it and repurpose it for our uses, but it meant that we had plenty of copper contact. And so there was no challenge whatever for us being able to deploy that in the field as quickly as possible and not have to worry about going back and redesigning. So not optimizing something too quickly allowed us to get things in the field and getting them working. So So I guess that then leaves us with the question of, so what does that mean for the wider kind of robotics community? And I think I would say one of the things I would love us to be thinking about over the coming few days is whichever elements of robotics technology which each of us are working on, be it complex artificial intelligence algorithms or battery chemistry or delivering machines into market themselves, how can we each make the systems that we're working on simpler so that it is easier for the next person down the chain, whoever our user and customer is, to integrate them and work with them, so that we can see them deployed into markets sooner, and hopefully we can get that vision that we all have of being able to see mass adoption of robotics. It was an interesting case study, I think, just last week. I heard on the radio Professor Paul Newman from Oxbotica talking about the fact that they were now considering, rather than targeting autonomous vehicles as the only market they were looking for, they were going to start looking at things like tractors and forklifts and AGVs. And I think that's probably an example of how you may aim for a simpler application in some cases to be able to get your technology out and used. So really looking forward to the next couple of days. Thank you very much for listening. I look forward to maybe chatting with some of you about how we can make robots simpler and get them into market and into use. Thank you very much.
We now come to the official opening speech by Dr. Bernd Liepert, our President of EU Robotics. Please, Bernd.
Thank you very much, Reinhard. Yeah, dear members of the European Parliament, dear Vice Principal of the Heriot-Watt University, dear Professor David Lane and local organizers, dear colleagues from the EC, especially dear Anne, thanks for joining us today. Happy birthday. Dear ladies and gentlemen, dear roboticists, welcome to the European Robotic Forum 2017 in Edinburgh. I'm glad to see different stakeholders of the robotics community convening who contributed to the success of European robotics in a market where robotics is on continued rise. Statistics show that Europe is a front runner in industrial robotics with a share of about 20%, and the robot density, the number of industrial robots per 10,000 workers in Europe, is among the highest in the world. Also in service robotics field, Europe has a strong position with a worldwide share of 38% in the professional application domain, with more companies and startups in the field than US, and I think that's a very big surprise. Robotics spread out into various domains, into professional services, domestic and personal use, which has already reached half the turnover of industrial robotics, and robotics, last but not least, plays a complementary role in Industry 4.0 or IoT settings. But Europe has to stay active and agile, as for example in 2014, China's president called for a robot revolution, and the US are also actively promoting robotics. Funding there will increase. We in Europe have now tremendous opportunities to make robotics innovation for all economic domains. We need to create solutions and products attractive for everyday life. Technology transfer that describes the process of converting scientific findings from research laboratories to innovative products, processes, and services by the commercial sector is a key to success. This unique chance for EU robotics is, for example, reflected in the Tech Transfer Award session run by Martin Hägerle and the Entrepreneurship Award driven by John Aguirre, Renaud Champion, and Jeff Pegman. The robotic startup culture is European, as the statistics have shown. All these developments also stimulate non-technical discussions regarding ethical, legal, and societal issues, where one prominent example is the Initiative for Civil Law Rules on Robotics. On January 12, 2017, the Committee on Legal Affairs of the EU Parliament, URI, has passed a draft report detailing recommendation on upcoming civil law rules on robotics. This includes a personhood status for robots, a European agency for robotics and artificial intelligence, a registration system for robots, mandatory insurance schemes, tax issues, and advisory code of conduct to guide ethical design, production, and use of robots, and many things more. On February 16, 2017, the European Parliament debated and voted in plenary on civil law rules on robotics. For 396 votes, against 123, abstentions 85. This means 2/3 believe it's a good idea. The Commission will not be obliged to follow the Parliament's recommendations, but must state these reasons if it refuses to do so. The committee has an open public consultation where positions can be submitted by April 30th, and EU Robotics will take a position. A series of workshops in the ELS track addresses this initiative from different perspectives, thus collected input from all stakeholders in a dedicated session. And please support us to make this really a good statement for the Parliament. Robotics raised a great visibility in the last year, and the power of the combination between robotics and artificial intelligence became more prominent. Communication not only within the technically oriented robotics community, but with all stakeholders, end users, component suppliers, politicians, and policymakers, the wider public, and the media is essential to communicate facts and to shape and promote the image of robotics in a positive way. Therefore, a track of sessions is dedicated to artificial intelligence and robotics, starting with a keynote by Roya Hetzel from Google DeepMind, while an entrepreneurial aspect is presented by the second keynote speaker, Stan Boland from 5AI, a company dealing with autonomous car technology. But dealing with artificial intelligence aspects does not mean, and that's very important, that mechatronics is solved. In contrary, only the combination of artificial intelligence with innovative mechanics, materials, and other hardware-related technology makes modern systems working and will lead to success. To stimulate these developments, the European Commission is driving the program Digitizing European Industry, and digital innovation hubs and platforms are new instruments to foster these developments. Juha Heikkilä, the head of the unit A1 within DG Connect, which is now named Robotics and Artificial Intelligence, will give more details on the EC's strategy. As in the past, the forum is meant to be a place for discussions, mutual exchange, insight in technical and non-technical topics, and a sort of family meeting of the whole robotics community in a wider sense, including end users, policymakers, investors, and all kinds of other stakeholders. With more than 750 participants, I think that was the number from 10 o'clock. Last year we had 729. The forum has again broken a new record, which allows discussions in 7 parallel tracks over the next 3 days. I wish you all of us a bright robotics future, fruitful discussions, and an inspiring forum. And hereby, I'm opening the European Robotics Forum 2017. Thank you.
So, good morning, ladies and gentlemen. My name is David Lane. I'm one of the general chairs of the forum this week. It's with great pleasure that I'm able to welcome Keith Brown, MSP, who is the Scottish Government Cabinet Secretary for the Economy, Jobs and Fair Work, who's going to come and say a few words to us from the Scottish perspective about how robotics fits in with what's happening in the nation here going forward. A few words about Keith. He served with the Royal Marines before pursuing a career in local government administration. He's an active trade union representative, or has been, graduate of our own Dundee University, where my son goes, so that's splendid, and studied at the University of Prince Edward Island. And he's been a member of the Scottish Parliament since 2007, holding a number of important roles, Minister for Skills and Lifelong Learning, Minister for Transport and Veterans, and so on. His current role as the Cabinet Secretary for the Economy, Jobs and Fair Work has a very long list of responsibilities associated with it, starting with the Scottish economy, and that's a huge thing to have on your shoulders. But infrastructure investment policy, increasing productivity, which is one of the key things that robotics is about, I think we all know, fair work, industry and manufacturing, cities, energy consent, and so on. So I think Keith is the Minister is absolutely the right person to be with us today, and it's a great pleasure to welcome him to the event. Keith.
Thank you very much, and thank you also for the invitation to this prestigious and influential event being held in the UK for the first time. I'm grateful to Professor Lane for the kind invitation and will happily take this opportunity to talk, as you would expect, very positively about Scotland, about our potential and what we're trying to do here. Scotland, as you will know, is a small nation, but we're very proud to be a vibrant, inclusive, open and outwards-looking digital nation. Digital skills, from the very basic through to the advanced capabilities on display here today, are absolutely vital, as has been mentioned, to Scotland's productivity. Scotland's First Minister made this very point in her speech last weekend. We have real strengths here in Scotland, particularly in informatics and data fields. We aim to build on these and support the development of these forward-looking sectors. Now, I am from Edinburgh. I don't know if you know, but I was born and raised in Edinburgh. And if you think about Scotland's heritage in terms of, if you like, innovation and also technology, Alexander Graham Bell, inventor of the telephone, although Italian colleagues may want to challenge that. John Logie Baird, I don't know why you have to have three names to have been an innovator in Scotland at that time, but John Logie Baird, again with the television, those two innovations alone, hugely important. And we have that heritage here in Scotland and want to continue with that. To that end, my colleague, Derek Mackay, who's the Minister for Finance in Scotland, launched a refreshed digital strategy earlier today. It's called Realising Scotland's Full Potential in a Digital World. And it describes the actions that we need collectively to take to ensure that all of Scotland can seize the opportunities that the digital age presents to us. So people, businesses and organisations across Scotland getting the tools and the skills that they need to harness that potential. So for us, our vision is that Scotland becomes even more digitally competitive and an attractive place for our businesses and citizens to share and participate fully in the process. And the strategy being launched today describes our plans for ensuring that we put digital at the heart of everything we do. It includes, for example, £36 million for a digital growth fund to help develop digital skills across Scotland. And that's because we recognise that digital skills are vital. They're essential to our aim of inclusive growth, making sure that everybody benefits from growth in the economy, but they're also vital to economic development, internationalisation and innovation. And as I've said, we have a superb reputation here in Scotland for innovation. There are many other examples, despite these small things like the telephone and the television, Dolly the sheep and many other things, penicillin and so on. But we have to build on that and not rest on past achievements. And we can do that by working in partnership with experts like those here to consider and understand fully the application of emerging areas such as the Internet of Things, artificial intelligence, robotics and machine learning. And I was saying to Professor Lane, I'd heard recently that a Japanese company had put an artificial intelligence on their board of directors recently. I mentioned this last night, and a number of the politicians were horrified that the prospects of being replaced in their jobs, although there might be some popular support for that, I would imagine. We obviously want to build on the success of our innovation centres like the Edinburgh Centre for Robotics, Census and Data Lab, and bringing together the public sector, business and academia. And we're also pleased the UK Government has recognised this in their spring budget, which announced investment in science, research and innovation. All of these things, of course, are key drivers in relation to productivity. And productivity has been a challenge both for Scotland and the UK for a number of years. Scotland has just recently almost closed the gap between itself and the UK, but even given that achievement, we still lag behind other competitors. So seeking new ways to improve that productivity is very important. And we also recognise the investment in the Edinburgh Centre for Robotics, and we'll be working with UK colleagues to ensure that UK investment continues to reflect Scotland's unique industrial and academic strengths. So our Innovation Action Plan, which was launched earlier this year, sets out some immediate steps to improve Scotland's performance. The plan aims to create a culture built around the idea of using innovation to grow. Our long-term ambition is to boost Scotland's innovation performance to match the levels of the best performing countries in the OECD. And that will enable long-term productivity growth in Scotland and, of course, the higher living standards that we want for our people. So for the Scottish Government, we'll always put the economy at the forefront of our ambitions and take the action that we need to in order to support our prosperity. We know that depends on the translation of our world-class research and ideas into commercial benefits. Fortunately, the research amongst our higher education institutions is one of Scotland's best assets. We have 5 universities ranked in the top 200 in the world. The 2014 Research Excellence Framework assessed 77% of our university research as either world-leading or internationally excellent. Scotland already has the largest concentration of internationally significant and world-leading informatics research in the UK. And the universities that we have here offer a mix of graduate and academic skills, as well as the ability to generate new ideas, products and processes, and that's the way it should be. So continually being successful to improve the business-university interface is important for addressing the opportunities and challenges that are part of fulfilling our economic potential. And the Innovation Scotland Forum has done excellent work over the last 3 years to improve the support provided to the interface between universities and businesses. So if we can talk a bit more directly, briefly about today's theme. Obviously, you're here to talk about robotics and artificial intelligence. Now, I understand that the worldwide market impact of robotics and autonomous systems is estimated at between $1.7 trillion to $4.5 trillion annually, with an emerging market value of $15.5 billion by 2025, and these are very big numbers. AI and robotics are, of course, built on data sciences and informatics, and that's an area in which Scotland already excels. We have an estimated 170 companies in Scotland firmly in that space of data sciences and informatics, and they're worth between them around £1 billion. The Data Lab Innovation Centre is involved in 45 projects worth around £60 million, but also has a further pipeline of 72 industry projects under discussion, so you can see how vibrant it is. In addition to that, Scotland's also developing 2 plans which will ensure even greater company engagement with data, AI, robotics and with automation as well. And the first of those is our Manufacturing Action Plan, which aims to provide access points to allow companies to experience and to experiment with modern industrial techniques. The second plan is the Data Opportunity Plan, which will increase company awareness adoption and exploitation of the value of their data assets and those of others. And both plans taken together, we hope, will accelerate the use of AI and robotics and automation throughout Scotland. Now, as you will know better than me, people do question the long-term effects of automation, but there are quite clearly opportunities, especially related, in my view, to Scotland's key strengths. So in financial services, we are making great advances in terms of fintech, and also in relation to oil and gas, a very important sector for Scotland, real advances in terms of subsea engineering. But we need to reskill, upskill and also repurpose our workforce and support companies so that we become net suppliers of expertise rather than just the passive adopters of the expertise of others. So the level of activity in this space in Scotland is accelerating. And in particular here in Edinburgh and in the South East Scotland region, there are currently over 150 industry-related challenges being lined up for exploration across all sectors, with many including artificial intelligence or robotics within their solution space. And beyond that Edinburgh cluster, our talents extend to include the wider Scottish Informatics and Computer Science Alliance universities, Census in Glasgow, and the Oil and Gas Technology Centre in Aberdeen. That centre recently opened with £180 million of investment from both the UK and Scottish governments. And the aim of that centre is to become a globally recognised go-to centre around oil and gas technological innovation. And oil and gas remains hugely important to Scotland. Robotics, as I've mentioned, play a critical role in subsea engineering, where remote-operated vehicles are commonplace. And Scotland's oil and gas industry has developed a cluster of subsea engineering companies which is among the strongest in the world. Around half of the subsea installations in the world today are in the North Sea. I went to the ADICEP conference recently in Abu Dhabi, and you can quite clearly see the influence of Scottish companies in development innovation for the North Sea over many years being impacted in other economies around the world. And to that end, we published our Subsea Engineering Action Plan in January this year, and that plan is designed to build on our existing strengths in subsea engineering, but also helping our oil and gas companies find new opportunities at home and abroad. Another sector which I'm sure you're aware is crucial is the health and social care sector. Scotland's a perfect testbed for new healthcare technologies that rely on the use of big data. As I've said, we have an excellent data infrastructure in place which supports an increasingly integrated digital health ecosystem. We are developing a new digital health and care strategy to ensure that health and care services in Scotland are making the most of robotics and artificial intelligence. And I know that in addition to Europe, various activities going on across Europe and Japan, this is also an economy which is facing an ageing population, which has real challenges in providing the skills necessary and the individuals necessary to provide the care to an ageing population. So a huge amount of emphasis on this. And also it's true that some of the newest hospitals here in Scotland, my local hospital, Forth Valley Hospital in particular, employ porter boards, robots that move medical supplies, linen and food and waste around the building, I think mostly fairly soundlessly behind walls. We also use robots and AI for clinical processes such as cancer surgery and diabetic eye screening, as well as hospital and community pharmacies in Scotland, where robots are employed to collect prescriptions from medicine stores. And NHS Scotland is also piloting the use of care robots to support people with dementia at home, as in the Japanese example that I gave. And that's particularly true in rural areas. It's also true to say that Scotland's very attractive for research in this area because we have perhaps the best set of NHS records anywhere in the world. And we're also a perfect size in many respects for that research to be carried out. So I've talked, perhaps not unexpectedly, about Scotland's achievements, strengths and plans. And we do have a lot to be proud of here in Scotland, but we also greatly respect and value our partnerships and our neighbours. And we recognise that we'll not succeed in this alone. We will always welcome European, national and international collaboration, which is actually embodied as part of this event here today. And I see that the programme that you have features both underwater robotics and health over the next few days, and workshops on the applications of robotics, which is truly fascinating. So I hope that you all have a fantastic few days. I hope that you enjoy my home city here of Edinburgh if you've come from elsewhere. And of course, the real value in these events is the exchange of ideas which take place, the inspiring new collaborations which can be arranged, but of course enjoying the sights and the hospitality of this great city. So can I thank you for the invitation to come and speak to you today, and wish you all the best for a fascinating few days at this conference. Thank you.
Good morning, all. It's my pleasure and honor to welcome all of you on behalf of the local organizing committee to the wonderful city of Edinburgh. It's very nice to see lots of friends from collaborations afar, but also it's a pleasure to host you here in this beautiful city. So I represent the Edinburgh Centre for Robotics, and this is a joint venture between the Herod-Watt Universities and Edinburgh University. And I don't have to impress upon the crowd here that robotics is massively important in ranges of application domains, from healthcare, autonomy in driving systems to even agriculture. So just a very brief word on what we are doing here in Edinburgh to push this boundary. We are creating world-class assets in terms of equipment that we work with. So we've got world-leading robotics facilities, as well as we are investing in people. We're investing in the next generation of PhD students, people we are training in this scheme of trying to push the boundary of robotics, and not just sitting in our ivory towers, but really looking at working with companies, with end users to try and push real innovation. And as you can see, lots of interesting and innovative companies associated with this endeavor. So one particular example of this project is an exciting project we have with NASA, and again, as an invitation, there's a lab tour tomorrow between 6 and 6:45, which all of you are welcome to come and visit. So I want to end here by just saying one thing. Yesterday was supposed to be the beginning of spring. We do things slightly differently in Scotland. We give you a slight snow shower to remind you of what you're going to miss. But please enjoy the weather, the city, our hospitality, and I hope you have a wonderful rest of the 3 days and have lots of fun. So it's my pleasure to introduce Juha as my next speaker. And once again, a very warm welcome to Edinburgh.
So, good morning, ladies and gentlemen. My name is Juha Heikkilä. I'm the head of the Robotics and Artificial Intelligence Unit at the European Commission. So, honourable members of Parliament, Cabinet Secretary, Vice Principal, chairs and members of the organising committee, ladies and gentlemen. It is indeed a great honour and pleasure for me to be here in Edinburgh today and to have the privilege to say a few words at the opening of the European Robotics Forum on behalf of the European Commission. And I would like to thank the organisers for giving me this opportunity. I would like to start, if I may, on a personal note, because that is, in fact, to confess that I have a bit of a soft spot for this great historic city. You see, at the tender age of 22, as an undergraduate of little experience, somewhat greater ambition and even greater curiosity, I spent 3 months in this city. Setu already mentioned the weather. Those months were January, February and March, so you can imagine that it wasn't exactly warm weather most of the time, but it was more than made up for the fact that the warm welcome I received was unforgettable, and of course the city with its attractions. It's always been a pleasure to be back, and it's a pleasure to be back again this time. But on to robotics. As many, maybe even most of you know, the European Union invests significant amounts in robotics. Between 2007 and 2013, in the so-called 7th Framework Programme, our total investment reached about 550 million euros, taken together all the smaller parts as well as the main robotics part that I represent. Since then, our involvement has, if anything, increased. Since the beginning of the current Horizon 2020 Research and Innovation Programme, we have already invested more than 300 million euros, this year's call for proposals including. This, of course, forms part of our commitment to invest up to 700 million euros in the context of the Spark public-private partnership for robotics in Europe. To our knowledge, in fact, this makes the EU program the biggest civilian program in the robotics area in the world. This may surprise some because the hype surrounding robotics often carefully avoids Europe. But this investment has borne fruit. We have a vibrant robotics community in Europe. Academia and industry are talking to each other, and they are working together more closely than ever before. Results are great, and they are gaining in maturity and moving closer to the market to benefit our citizens and economies. I already mentioned Spark, the partnership between the European Commission and the robotics community. This engagement with the community, with the stakeholders, is, in our view, essential. This is in order to ensure that we have the right strategy in place for robotics in Europe. We put a lot of emphasis in this work, in partnerships, in European Commission across our activities. And this has also led to a more sustained commitment to invest in the area and to ensure continuity of the activities. So why do we do this then? What's the point of all of this? Well, it's quite simply because we want to ensure that Europe stays at the forefront of this technology, and the amounts we have put on the table show that we are serious about this. As I already stated or hinted at, Europe has great researchers and great companies in this field, but it is not always sufficiently well known and appreciated. We can capitalize better on what we have by joining forces and by working together. And this is indeed what the EU funding is meant for. Moreover, staying put, resting on your laurels is not an option, as the Cabinet Secretary already pointed out, because the rest of the world is not standing still. There is a saying that you never change a winning tactic, but in fact, if you think of it, this kind of an attitude has the seeds of your next defeat already built in, inevitably, perhaps even imminently. Some might ask, so what? Why does it matter if Europe is not at the cutting edge of robotics? Well, I don't think that this audience needs a lot of convincing to say why this is the case. Maybe 20 years ago, people would have been a bit more blasé about it, but not anymore. With double-digit growth rates and with a huge economic potential, we simply cannot afford to miss the boat. This is all the more so because artificial intelligence has come back with a vengeance. For many, certainly many in the audience, it never went away in the first place. It is, in fact, a component in virtually every single project we fund, to a greater or lesser extent. But greater computing power, vast amounts of data, and advancing learning technologies have made it even more relevant than before. This is then the reason why artificial intelligence is adding a component to this mix, and it is set to feature more prominently in the future. And we have to make sure, therefore, that Europe counts in this respect as well. And in the European Commission, we are preparing for this challenge. Robotics and artificial intelligence are, in fact, among those technologies which drive a major process of digitization that is taking place in our economies. This leads to the transformation of products, production processes, and business models. There is more digital in all kinds of products, value chains are being reshuffled, and the boundaries between products and services is blurring. If you think of the fact that this digitization process is estimated to have the potential to add 1 trillion euros to the GDP of our economies in the next 10 years, and when you think of the fact that almost a third of the overall industrial output growth in Europe is already due to the uptake of digital technologies, it goes without saying that we are talking about a major transformation here. To seize these opportunities, the European Commission has therefore launched the Digitizing European Industry initiative that was already mentioned by Dr. Liepert in his opening statement. It has a number of action lines, but just to mention two, they include worked with partnerships, as I mentioned, like Spark, to ensure that we have European leadership in key technology areas, platforms, and value chain. Another key aspect is to enable companies of all sizes to access digital technologies and expertise within working distance. This is achieved by means of the so-called digital innovation hubs, which are built around local or regional competence centers, and they are instrumental in propagating the technology among companies that can benefit from it. So, robotics and our activities to advance it are therefore an integral part of this strategy. And I would like to emphasize that, in case it wasn't clear, that this concerns not just industry, but also innovative new services. Robotics has, of course, long since moved out of the factories onto new terrain, and the presence of robotics will be felt and will become more evident in all walks of life in different forms and in different kinds of services. So as you can see, the European Commission is serious about robotics and artificial intelligence, and the activities form a bigger picture aligned with a strategy that is to bring benefits to our citizens and economies. Our work programs, their structure and priorities, which we have drafted based on the strategy that has been defined in the partnership, are then shaped to support this strategy and to drive it forward. So this is then the backdrop against which the European Robotics Forum takes place. I hope they will have become clear by now why the European Commission values this event so greatly. It is instrumental in forging and strengthening the partnerships, and these partnerships are then essentials in combating fragmentation and in supporting and promoting European leadership in this area. This event is in fact special in bringing together a broad mix of academia, industry, and other interested parties. In fact, I was told yesterday evening that this is unique as an event in this respect in the world. Edinburgh, as a centre of excellence for robotics, is of course an ideal location for this event. But even if we disregard that for a moment, a forum is a place of discussion and exchange of ideas and views. What better place then to hold such a forum than Edinburgh, the centre of the Scottish Enlightenment? I'm also convinced that many of the discussions at this event will be conducted in the same spirit of improvement and practical benefit to the individual and society as a whole that guided that movement. So on behalf of the European Commission, I would like to welcome all of you to the Robotics Forum. I wish you very stimulating and inspiring exchanges over these 3 days. Thank you.
One of the things that's very important to EU robotics as a community, obviously, is the science, in this case, robotics science that we pursue. But it's also the translation of that science through innovation into economic benefit. And many of the projects that are being supported by the European Union at the moment, are very much have that in mind as part of their focus. My experience in doing some innovation is it's not the number of companies that you start that matters, it's the number of companies that you exit successfully that is one of the marks of success. And so we're deeply honoured, I think it's fair to say, to have our next plenary speaker, Stan Boland from 5AI, come to talk to us. Stan, I don't know if anybody calls him this, but I will, is a one-man unicorn. And the reason is because $1 billion in company exits. Think about that, $1 billion, not $1 million, $1 billion in company exits from his previous work in 2-3 other startups in Broadcom and NVIDIA, served as CEO of the computer pioneer Acorn, member of the board at ARM Holdings, graduate in physics from University of Cambridge, and in 5AI has started up a business which we're going to hear about with 2.7 million of venture capital funding behind it. And this is something that I know is either in the minds of people here or is something that they're already doing. And I think it's great to have somebody of Stan's caliber come and talk to us about 5AI and starting businesses. Stan.
So thanks very much, David, and thanks to the European Robotics Forum for inviting me to come and talk today. You are such a daunting audience to come and talk to, because my background is really sort of communications and semiconductors, and here I am talking about a robotics startup. So I definitely feel as I'm going to tread on a few toes and say a few wrong things. So I hope you'll forgive me for that. But what I'm going to talk about to begin with really is why. Oh, it's that one, is it? Oh, thank you. Well, why I think there is actually an amazing opportunity here to build some really, really cool companies, and that, in a way, is what we're going to try and do in our own way at 5AI. So I'm going to talk mostly about 5AI, but I'm going to start, though, by talking about the overall background that we have and why I think we've got this amazing chance to sort of do some really exciting stuff here. So yeah, I think I actually start with looking at Europe's talent. So if you look at world university rankings for computer science, obviously a core expertise, maths and computer science, for all of the stuff that we're working on. It turns out that we have 6 of the top 20 global universities here in Europe. In fact, 7 out of the top 25 here in Europe. So if you look at the quality of research, where that research gets published, how often it gets cited, how important it is, it turns out that we are absolutely the same level as Stanford and NYU and Carnegie Mellon and MIT and so on. So we absolutely have the expertise to do that in Europe, and so we've got some amazing raw talent. I think also one of the other things that has changed, I mean, really beyond recognition, really, from when I first did a startup and we were knocking on the doors of venture capital firms. I remember knocking on the doors of Schroeder Ventures, and at the end of this presentation, they said, "Yeah, but what you're proposing, that's risky." We say, yeah, of course it's risky. Yeah, we thought it said ventures above there. Yeah, But nowadays, the amount of money actually going into technology startups in Europe has grown dramatically. Just since 2011, there's actually, I can't believe these statistics actually, but there's a 5x growth in the amount of money being invested in startup companies in technology here in Europe. So almost $14 billion invested last year in technology startups, which is absolutely staggering. So there's definitely appetite, partly because there's so much money sloshing around the world economy, I think, but there's definitely appetite to invest in technology startups and do that here in Europe. So, but actually, there's a few things that are not quite right. One of the things that's not quite right is that when we look at where our top PhD alumni go, given that we are educating people to the same standards as the top global universities, actually half of those people, almost half of those people either stay in academia, which I think is fine, or they go to financial services, which is a sort of UK disease, really, or they go off to be CEOs or CTOs of a company, which is also fine. So half of them you can kind of account for in that. But of the remainder, 4/5 go to US tech companies. So I like US tech companies, but if you actually look at the top schools, I just looked at Andrew Zisserman's group in Oxford here, which is one of the biggest alumni group, and just ticked off where they'd all gone. They actually go to Facebook, they go to Google, they go to Microsoft, they go to Apple, they go to Amazon. So 4/5 go there, and roughly a 10th stay and build real technology companies here in Europe, either in the UK or across the rest of the EU. So that is a massive mistake we're making. So we're educating people to this great standard, and then we're letting them all fall through our fingers, really. So it's incumbent on us, I think, to build exciting, configured companies here, get some venture capital behind it, offer stock options to people, and allow us to sort of create some really great companies and have the staying power to take them all the way through to significance on a global stage. When actually once a year, Atomico and Slush do a survey of a huge base of people across European technology, and one of the questions they ask is, do you agree or disagree with the statement that now is the best time to be a European tech entrepreneur? And actually, only 5% of respondents disagree, 35% agree, and 45% strongly agree. So that's a 16-to-1 ratio of people in this space who think that now is the best time to do this, really. And I mean, the space that we're all sort of getting into or in, I think is certainly the most exciting space to kind of build companies in right now. So as David mentioned, I've been like super lucky in just meeting really smart people and finding a way of working with them. So I actually joined a company, Rolls-Royce, an aerospace company, spent 6 years there, joined as a graduate engineer, joined a couple of companies, joined ICL, a computer company based in the UK, just when Fujitsu bought the majority stake in it. I actually joined Acorn, ended up being CEO of Acorn, actually towards the end of its life, actually, ended up breaking it up and selling it up in pieces. But one of the things within that is there was a team of people there who'd actually designed the original ARM instruction set. They're not actually joined ARM, but they're kind of really instruction set people and embedded software people. And we basically configured a company to build a new type of core that we actually applied to signal processing. In fact, we applied it to a particular market vertical in signal processing, which is fixed line communications for broadband access, so DSL chipsets for central office. And we sold that company, actually not much later, having founded the company, sold it to Broadcom for $640 million. We'd raised 13 million of venture capital, and we managed to return 32x to investors on that deal. So, I mean, that is quite hard to repeat. And it was a sort of state of the industry at the time. We actually took stock in the company. It was a massive mistake. We should have taken cash, but anyway, you live and learn. So I spent about a year working at Broadcom, working with a guy called Henry Nicholas, who, if you know him, is a nutter. So then anyway, I formed a new company called Icera with some ex-colleagues. We decided to focus instead on cellular, mobile phone chips. In fact, the most complex problem in a mobile phone is the modem technology. So we ended up building a new type of processor, baseband chip, radio chip. All the software basically runs in a mobile phone for 2G, 3G, LTE. And that was a labor of love, actually. We grew that to 320 people over quite a long period of time. Had to raise a lot of venture capital. We definitely did not return 32x on that company, but we did sell that company to NVIDIA in 2011. For 420 million, which was a miracle because pretty much everybody else in that space was losing billions, and we managed to actually make money and sell the company to them. So we were pleased with that, and so I spent about a year working for NVIDIA. I joined a company in Cambridge called Newell, which was a basket case. I shouldn't have joined it, actually, but it was already going. Raised another 5 million of capital and managed to get that sold to Huawei for 25 million. So it's not a fantastic deal, but got that deal away. And then basically decided I'd form a new company in a completely different space I know like nothing about, but we're desperately learning. So the paper that Ryan mentioned, I've read it. I've looked at the reports on it. It's a fantastic piece of work. Definitely recommend everybody reads that, plus lots of other research. We're building a company called 5AI 5 because the top level of driving autonomy is level 5. So we're aiming ultimately for full autonomy in vehicles. So what I'm going to talk to you about is 5AI. We believe that it's time to build a kind of moonshot mission for a technology company here in Europe. And we think that the opportunity to do that is apply AI in vertical market stacks. So it is definitely possible to build horizontal layers of technology and license that, but we think the real kicker comes from when you basically apply that in a market vertical. The market vertical we like best of all. It's got lots of challenges, but the market vertical we like best of all is driverless cars. So we're actually not going to divert from that. We're going to be laser focused on solving that problem, and we're going to build a large, scalable, valuable business through leveraging superhuman perception and prediction AI to deliver safe, urban, autonomous personal mobility services in our towns and cities. So there's a few kind of keywords there. So we're going to take it to market as a service business. I'll explain why that makes sense in a minute. And it's got to be safe. So it's got to be verifiably safe in our urban cities, which is the most complex driving problem that there is today. So it truly is a moonshot mission. So that's my imagery there of we're going to that place called the moon on our little rocket. And in fact, you've got to view this as a series of phases. So phase one is, let's escape Earth's gravity to begin with. So let's view it as a stage-set process. So that is really all about building the team. So we have to really encourage the smartest people to come and join the mission and pick up pieces of the problem, be expert in it, and help us build this kick-ass solution that is going to sort of solve these kind of significant unsolved challenges in AI. Our company is at the moment 20 people. We need to grow the team to about 120 people to get to that kind of first stage. So anybody who really wants to be part of a moonshot mission, who wants to kind of really see how their skills get leveraged in a vertical stack company, come join us. We'd love to talk to you, and we'd love to sort of have you work on some of our challenges. So we need to develop world-leading AI capability. I mean, DeepMind definitely already has that, so huge respect for them. We need to do something similar. And we need to build an end-to-end autonomous vehicle system, and we want to better pilot that in a major city. We're actually choosing at the moment to do that in London, because it's Europe's only megacity. And we have a pretty good partnership with Transport for London, who seem very keen to kind of work with us on that. So that gets us to a pilot system in a major city in 2019. Phase two is then we decide that we're going to set off for the moon at this point. So that's my little track of going to the moon. You see the moon is slightly bigger on this chart, and the Earth is slightly smaller. And that here we need to partner with the different operational layers of service. So there's definitely things here we're not interested in doing. We're definitely not interested in cleaning cars or maintaining their systems or charging them up at night or managing their life cycle. We're also not interested in some of the sort of utilitarian service levels like dispatch system and operational control and user app and so on. There are a bunch of regulatory issues to solve, which we're going to have to work very closely with government to get fixed. Geneva, Vienna Conventions, UN Student Regulation 79 and blah, blah, blah. And then we've got to get ready for a commercial launch. So that takes us to, we think, sort of 2021, hopefully first half of 2021, where we're actually ready to launch commercial services in our cities to transport people using autonomous vehicles. And then phase three, you see the moon is now really big here, is we're going to land this sucker on the moon, which means that we are going to really need to gear up significantly. The venture investment that we placed with significant capital that would allow us to lease vehicles or buy vehicles, and we'll be able to do that across multiple cities. So there's obviously a ton of learning we ought to do to that. That honestly is a low risk. That's a Goldman Sachs type risk. That's why they write a $500 million check, and with almost no technology risk or market risk, and is a decision we can push down the line and take later. So that's the way we're thinking about how we do it. It's a series of phases, really. That company, assuming we last the course, has the potential to be a huge public company. So that's kind of our goal. So our team, so I mentioned that I've done a few kind of startup companies. I've managed to find an initial starting team. None of the initial team really come from the AI space, although they're mathematicians or they're communications theorists or they're cryptography algorithm experts or they're engineers. But we managed to pull a team of people that originally founded the company together, including a marketing guy who spent 6 years working for an automotive semiconductor company, NXP Semiconductors, based in Hamburg. We have strongly helped the team by engaging with some key academic advisors. Our chief scientific advisor is a guy called Phil Torr. So Phil runs the Torr Vision Group, is a professor at Oxford, and he is probably one of the most cited researchers in computer vision and deep learning. And here in Edinburgh, we've been really lucky in finding Subramanian Ramamurthy, Ram, who is advising us on our behavior motion prediction and is helping us sort of figure out our architecture and help us build a team around that. And we've also signed up Andrew Blake as an advisor. So Andrew was the director of the Alan Turing Institute in London, now is the research director there, and is very much the kind of godfather of the computer vision world in the UK. We've hired since, actually I've got to show 10 more people there. We've got another 3 people in the pipeline. So we've actually hired in total 20 people. So, since we actually got our seed funding last July. And we've raised $2.7 million in that seed round with 3 investors. Amadeus funded the last 3 companies I've done. Kindred, the guy on our board, is a guy called Mark Evans. He put $50 million in our last company when he was at Balderton. And Notion Capital is a really sort of smart group of investors who are rotating into AI and machine learning. So from a system viewpoint, we define a platform. In our case, we certainly envisage that platform having a high number of sensors, high performance sensors around the vehicle. So typically 8 to 12 megapixel cameras, typically 60 frame per second sampling rates, different dynamic ranges, different light sensitivities with LiDAR units, IMUs, radar, so a high sensor suite around the vehicle. We then have an intelligent perception pipeline. And we have a kind of motion prediction and behavior prediction and motion planning pipeline. So there's a bunch of subtasks that we can define in that pipeline. So this is the kind of classic way of building a system, leading to a kind of 3D reconstruction and ability to sort of create our own map as we go and localize ourselves on that map. And then having observed the motion of objects in the scene, and obviously in the context of semantic segmentation, we might use inverse reinforcement learning, for example, to learn reward functions that can then inform how we might predict those objects that we see on runtime might behave. To be able to predict trajectories, I've shown it as a trivial box there. In fact, we need to use things like game theoretics to sort of work out exactly how those individuals will act and so on. And then to iterate that forward in a multi-body predictive model, to plan our local decision, what decision we take, control a vehicle, and then have some control loops around that. So that's a sort of a set of mediated subtasks that you can imagine we have as a pipeline. Some of those already sort of use deep neural networks, which are trained. And those obviously require some labeled training data to do that. So some of that labeled data we will buy or we'll generate ourselves, but actually quite a lot of it we'll create in synthesis as well. So we can create an accurate 3D gaming model of the world. We can actually generate lots of training data because we know the semantics of every pixel, we know the depth of every object and so on to a high level of perfection. So we'll use high levels of synthetic data. We also use unlabeled training data for some of these tasks, and in terms of the learning behaviors, we will be able to use things like traffic feeds and YouTube videos to be able to sort of train up these networks and to be able to then curate a library of learnt behaviors that we can actually then instantiate in our model for things like generating regression test suites for verification. So one of the benefits of designing a system this way is you do actually have human-readable interfaces. So Ryan mentioned that end-to-end learning is sometimes viewed as a black box. It obviously is not, but one of the benefits and one of the, I think, initial necessities of this space is to be able to explain to regulators and insurers why something went wrong. Because I mean, these cars and systems will definitely have accidents. They will injure people. They will kill people, and we definitely need to be able to say, we made a wrong prediction. We estimated that this object was 3.2 meters away, and it was 2.7 meters away, or whatever the fault needs to be. So we start, if you like, with a ground which I think we might have to have actually of mediated subtasks, even though we know that is not necessarily the most accurate way of actually solving this problem and not necessarily the best way of solving it. So some of those individual tasks we'll just replace with neural networks. So things like the analytic approach we take to visual odometry, we can learn that in a neural network. Things like the control of a vehicle, we can learn some of those functions as well. But there is really good evidence, as we just heard, that using end-to-end learning has a hugely beneficial effect in terms of the accuracy of some of these processes and systems. So we definitely plan to do that. So I've written no intermediate human-readable states. That's not really true, actually. We will definitely build in instrumentation that allows us to explain the AI even in those end-to-end networks. But from a simplistic viewpoint, that's the way we'd regard it. And you can imagine that we might teach those networks using some local utility rewards, things like consistency of motion from frame to frame, or the consistency of classification from frame to frame, or we might look at some ground truth from LiDAR data or whatever it turns out to be. So we've got to train those networks with some utility rewards through them. And we'll end up with a large number of parallel high computational processes running in a vehicle at any point in time. And there'll be different routes through that, and we'll eventually learn for an individual context, what is the most accurate way, basically, of navigating our way through these network of processes. So we'll have intelligent agents trained for utility and end-to-end rewards in our entire system. But the key point here is that we're going to be doing a lot of computation on a vehicle. In fact, we think that to be safe in an urban environment, we might need to be doing as much as 200 trillion floating point operations per second in the vehicle. So just put that number in some context. The last company, the significant company I did, we built a chip that did 30 billion arithmetic operations every second for LTE modem technology, and we thought that was screaming edge. So here, we're talking sort of 1, 2, 3, 4 orders of magnitude more in terms of computation that we're going to be running in a vehicle, and the floating point operations. And in terms of the total amount of camera pixels, that's also going to be quite high, but it's going to be necessary to do that to be safe in our urban environments. So today's visioning systems probably miss something like 25% of cyclists, so misclassifies them. So that's a massive problem. So we absolutely need to have very high precision and very high recall in these systems. So that means that costs money. So the total budget to do that in a vehicle is probably more like $30,000 to $40,000, not the $10,000 that Elon Musk would have you believe on the Autopilot 2.0. And so if you actually limit the amount of computation in the cameras you put in a car, you are limiting yourself to highway driving, which is a much simpler problem, or to guided urban environments and so on. And that if you really want to deliver something that is safe in urban environments that people can rely on, the insurers will underwrite, the regulators will approve, it's going to have to be pretty powerful. And we think a service model can afford that, because although we as humans might not want to pay $40,000 extra for sensors in our car as a gadget, although some people will, we would be quite happy to pay for a service that transports us from A to B, where the cost of that service was significantly less than a driven drive. And if the cost of that turns out to be 30 cents per mile, that's actually pretty cheap, actually, compared to driven cars. So competitively, I think there's 3 groups of people doing this. There's a bunch of startups, there's large tech companies, and there's automotive companies. So it falls into those 3 categories. Some of those startups have raised a lot of money. Probably the biggest of the startups is Zoox, which actually has a whole load of Brits working for them, by the way. There's some exiles from Europe that really should be doing something here, but there you go. And actually, we put them on a chart of the y-axis being access to cash, and the x-axis being access to talent. And one of the things you notice is that the automotive companies just can't access the talent. So in our view, tech companies are going to win. In fact, none of the graduates of top schools are going to automotive companies. They're all basically going to tech companies. So tech companies are going to win, in our view. We would say that because we're doing this here in Europe, because talent pools are so strong, and because we can configure companies that are attractive, we can give people significant stock in the company, we have a privileged way in which we can actually access talent and build talent here. So we put ourselves further to the right, but obviously we've got a lot less cash, so we will need to raise some cash. And if the goal is to get to a kind of safe urban driving, we think you can get there with talent and a bit less cash, or you can brute force your way there with cash. And our view is we've got as good a chance as other companies to get to a safe urban driving experience ahead of other people. And we think that the regional differences will also be quite interesting here. So if you turn that chart through 90 degrees and look at a geographic axis, actually different cities, different regions have different kind of behavior. So even if Uber managed to get a service working in San Francisco, which is a sort of motor city with a grid-based system with a certain type of human behavior, it's probably not going to work in Bologna, in a medieval city with Italian behavior, and it's probably not going to work in Delhi with Indian behavior and with the topologies that are completely different there. Plus public transportation, maybe the city of San Francisco doesn't really care if we cannibalize buses and train services, but actually London really does care, so it really has to kind of fit in, I think. So I think the message we'd have is no single global vendor is going to dominate the market for delivering autonomous vehicle services. And of course, as a startup, you can build the technology, which is obviously what we're doing, is an essential piece. It's got to be integrated into a vehicle, and in our view, it's got to be delivered as a service. Some companies are doing just the technology, so Mobileye is a good example of that, just bought like 2 weeks ago by Intel for 15 billion, so that's a fantastic result for them. Some companies are doing the technology plus the vehicle, so Tesla is doing that, for example, and some companies are doing the service plus the technology, so that's what Uber's doing, and it's just, that allows them, their call to an OEM is not, please consider taking my technology, and you might be in a model in 7 years' time if you're lucky. We want to buy some cars, so we have this technology, and please sell us some cars. So it's a completely different relationship they have. That's the model we prefer, basically, is doing that. And then some OEMs are going to try and do all three. So the market, we think is a big market. By 2025, autonomous vehicle mobility is going to be of the order of $240 billion globally, much, much bigger than the licensing business for software, and obviously comprises a whole bunch of different inputs to that that would need to be integrated. And what I'm going to finish with is just show you, we've not been doing this for long, so I hesitate to show you any of this sort of video footage, but these are just some of the subtasks. I'm not going to show you any of the end-to-end learning stuff we're doing, just some of the mediated subtasks that we've got, and we're just going to show them as a collage of kind of work in progress, really. So I'll start with, we're doing stereo depth mapping here analytically, so what you see is a point cloud. Each point is a feature that's been extracted, and we're looking at the stereo disparity from that, and you can see that we're able to sort of put that in three-dimensional space in terms of depth map. We've fused it with LiDAR, so some of the lines you see in red, those are sort of LiDAR lines that we fused together, and the visual odometry track, which I'm now going to show you here, we're using pure pixels to basically figure out where we are in three-dimensional space. Using patch selection, we're looking at pixel warp from frame to frame on those patches, and we're able to detect accurately, which we can put a map on later to show that we can follow our way around a track. And in fact, just to show how accurate it is, we actually arrive back at the exact point that we started at. So we're able to do that entirely with optical flow through the system. It's on a test track in Millbrook in Bedfordshire. Obviously we do object detection, so we haven't got that many labels in here, so that van is actually labeled as a car, so I apologise about that, and that we haven't got that much training data yet, and how exactly we'll end up doing this is definitely a work in progress. And we do things like semantic segmentation. It's currently quite messy, so we're going to basically add things like conditional random field loops as recurrent neural networks in here to kind of clean up these images. We're detecting lanes here, so we're going backwards and forwards deliberately here in order to use it for lane detection, and on runtime we're able to detect those lanes quite accurately on a road like this. And we could do things like take a view from a camera and create a kind of accurate bird's eye projection, which will turn out to be quite useful. And then that results in us being able to sort of plan our path accurately. So we've populated a few of the boxes, and we've got stuff that works together. We've got two cars. We were able to sort of sense the world, control those cars, and drive around tracks with them. And it's the very starting point of building this thing. So summary, we're building an amazing team with help from world-leading academic talent, including here in Edinburgh. So we're setting up a research group here, by the way. Urban driving requires superhuman perception, behavior prediction, and rigorous validation in simulation and on the road. Market is huge, and no single vendor is going to dominate globally. So it really is all to play ball. Thank you very much. Thanks.
Thank you, Stan. Don't you just love the ambition? I think that's fabulous. Right? Time for one question. We're horrendously late. There will be dinner, the lunch still downstairs, by the way. So time for a question for Stan. Stan's going to be around all today, but is leaving sort of tea time-ish, I guess, to busy guy. So do find the time to nail him and ask all sorts of questions. I know you have, but let you get your lunch first. And thanks a million, Stan, for coming. Really appreciate you were able to come and join us today. Thank you.
Thanks very much.
Yeah.